Okay, 1.3 is called solving equations with variables on both sides. So so these equations have the x's on both sides of the equation, and here are some steps that you can go through to solve these. So first of all, solving means finding the x value that works in these equations, that balances out the equation on both sides. Okay, so if there are any parentheses, you'd want to eliminate those first by distributing. Now these two don't have parentheses, but the problems at the bottom of this first page do. So the next step would be to simplify each side. So I'm looking over here. There's nothing to simplify on the left or the right here. Same with this one. But if there were like terms, like if I had 2 plus 3 on one side of the equation, I would simplify that. Okay. And you also want to collect variable terms on one side of the equation. Okay, so here I have x terms that are on both sides. So I want to get those on the same side of the equation. And so there's two ways to do that. I could either subtract 3x from both sides, or I could subtract 2x from both sides. It doesn't really matter. You could go either way, but I think for me, I'm going to subtract 3x from both sides just because I want the x's on the other side from the 5. And you could, if you subtracted 2x, that's okay, and you just have to move one of the terms later on. It would just add one extra step. But that's what I'm going to do first here. So then these 3x's cancel, and I'm left with 5 equals 2x minus 3x is negative 1x, or just negative x. Okay. So I've collected the variable terms on one side and the constant terms on the other side. And then I want to combine like terms that are on the same side of the equation. I don't have any like terms, but I just combined those two on that right side. Okay. And then I want to use the order of operations in reverse. Notice this is PEMDAS in reverse. So here there's only one thing to do at this point, so I don't really have any big decisions to make here. So here I know what negative x equals. I want to know what positive x equals though. So what we can do is either multiply both sides by -1 or divide both sides by -1. I'm going to divide here. So negative x divided by -1 is positive x. That's what I wanted. And on the other side, a positive divided by a negative comes out negative. So this is -5. Okay. And on all of these problems, once you solve for x, if you're not sure about your answer, you can go check it. And the way you would check it, take the -5, plug it back in for the x, both the x's in the original equation, and see if it balances out. So here I'd have 3 times -5 would be -15 plus 5. That would give me -10 on the left side. 2 times -5 would also give me -10. Okay, so it does work, and you could always test those out like this. Okay, so let's try this next one here. So there's no parentheses. So next thing, I want to simplify each side, but there aren't any like terms on the left. There aren't any like terms on the right. So nothing I can do there. Okay, then I want to get my x terms all on one side of the equation and the constant terms on the other side. A constant, by the way, is just a term that doesn't have a variable like the -2 or the -5. Okay, but I've got these two like terms here. So, these are like terms and these are like terms. So I want to pull the x's to one side and the numbers to the other side. So I'm going to first move one of these x's. You could either subtract 2x from both sides or x. I'm going to subtract x, just that because then my x's will stay positive. You could go either way though, okay? So those will cancel over here, and now I've got 2x minus 1x is x. Okay, I'm left with this. And I've still got these like terms here. I want to move all the numbers to the right side, so I'm going to add 2 to both sides. You could add 5 to both sides, but then you'd have the x and the number on the same side of the equation, and you'd have to move it later on. So that way I'm combining those and isolating the x at the same time. So then x is going to equal -5 plus 2 is -3. And again, you could go check that if you like. Okay? All right, let's try some that are a little bit more complicated down here. So first thing here, I do have some parentheses. So I'm going to distribute here and here on both sides of the equation to get rid of the parentheses. Okay, so 6 times 2 is 12. 6 times -4x would be -24x. -3 times 5x is -15x. and negative 3 times 2 is negative 6. Okay, and now it's looking a lot more like these original problems. It looks more like this one. Okay, so I've got the two x terms. I want to get those on the same side of the equation. So I could either add 24x to both sides or 15x to both sides. I'm going to add 24x to both sides. I prefer the x term to be positive. So if I do that, the 24 is bigger than the negative 15, so it'll come out positive. Okay, so let's see. I've got 12 equals negative 9x minus 6. Negative 15 plus 24 would be negative 9. Okay, or positive 9. What am I talking about? Positive 9. My bad. Here, I'll just scratch that out. All right, so I was just saying that was going to come out positive. All right, and then I've got the x over here. I want to combine these two, and I also want to get the numbers on the other side from the x. So I'm going to add 6 to both sides so that the 9x is on its own. Okay, and this is the step where you'd want to use PEMDAS in reverse. There's two things you need to do to isolate the x here. Divide by 9 and add 6. But the way you can tell which to do first is PEMDAS in reverse. So, adding or dividing is how you get rid of the negative 6 and the 9. And the addition subtraction come before multiplication and division and when we're solving for a variable. It's flipped around from if you're just simplifying an expression. Okay, so then I've got 18 equals 9x. And then the last step would be to divide by 9. It's the opposite of multiplying by 9. And then x is going to equal 2. Okay. All right, let's try another route. I'm going to distribute here. And I'm also going to distribute on this side. So let's see, I've got negative 6x minus 36. Negative 6 times 6 is negative 36. I still got the plus 8x there. On the right side, 5 times 5x is 25x. And 5 times 2 is 10. Okay. All right. So now I'm looking. I do have some like terms on the left side of the equation that I can combine. I can combine these two, right? Those are like terms. So let's combine them. Negative 6x plus 8x would be 2x. Okay. And now it looks a lot like the previous problem, so I want to combine these x terms, so I can either subtract 2x or subtract 25x. I'm just choosing to keep the x's positive, so I'm going to subtract 2x instead of 25x. So those cancel there. Let's see, I still got negative 36. Don't forget that negative is still there in front of the 36. Often I see people lose the negative there, but it's still there. 25x minus 2x is 23x. Okay. And now, to get this x isolated, two things I got to do. I'm going to have to divide by 23 at some point. I'm going to have to subtract 10 at some point. And PEMDAS in reverse tells me that I'm going to subtract 10 first. And also, I want to get the numbers all on one side of the equation. So that will tell you the number terms, the constant terms. So that can help you figure out what step to do first. So then I've got negative 46 equals 23x. Last step is divide by 23. I have to start writing smaller here. Negative 46 divided by 23. Well, that'll come out negative because a negative divided by a positive. And 46 is twice as big as 23, so it comes out to negative 2. And there's my solution. Okay. Okay, sometimes when we are solving these equations, strange things can happen. So sometimes we'll get a situation where when you're combining the x terms, we'll say when you're, adding 3x to both sides of an equation, both of the x's will cancel out. And then you'll be left with something strange like 7 equals 10 or 13 equals 13. Okay, and if you get one of those situations, then if the statement you're left with is true, so if there's no x's left or no variables left, and the statement is true, so let's say you had 13 equals 13, for example, that's a true statement. 13 does equal 13, and if you're left with that, then that means there are infinite solutions. Okay, so that's when the statement is true. If the statement is false, like 7 equals 10, well, no, it doesn't. 7 does not equal 10. So if you get something like that, then there are going to be no solutions. Okay. All right, so let's take a look at some like this. So I would distribute on both sides here first. To get rid of the parentheses, 6 times x is 6x. 6 times 4 is 24. Okay, 3 times 2x is 6x. 3 times negative 5 is negative 15. Okay, and now, hey, I want to get the x terms on the same side of the equation. So let's say I wanted to move them to the left. Well, then I'd be subtracting 6x there, and those cancel. But wait a second, these cancel too, and now we're left with 24 equals negative 15. What the? It doesn't tell me what x equals, right? But I've got one of my special situations here. So this is not a true statement. This is a false statement, right? 24 does not equal negative 15. That tells me there's going to be no solution. That just means that there's no x value that you could plug into the original equation that will make this true. That'll make it balance out, okay? All right, let's try another one. This one's pretty similar to the last problem. I wish it were a little more different, but too late. Okay, 3 times 2x is 6x. 3 times negative 5 is negative 15. 6 times x is 6x. 6 times negative 4 is negative 24. Okay, so again, when I want to combine the x terms, I'm going to subtract 6x from both sides. Then both of those cancel out at the same time. And here I'm left with a false statement. Negative 15 does not equal negative 24, so that means, again, no solution there. Okay. All right, let's try some more out. So here I'm distributing negative 2 to get rid of those parentheses and distributing 4 over here. So let's see, negative 2 times negative 2 is positive 4. Negative 2 times 4x is negative 8x. 4 times negative 2x is negative 8x. And 4 times 1 is 4. So when I combine these x terms by adding 8x, again, both the x's drop out. But this time I'm left with 4 equals 4. And that is a true statement. And when you get a true statement, infinite solutions. And that means in the original equation, you could plug in any x value and it would work. Because these are really equivalent. They're the same. They're just the terms are flipped. So no matter what x you plug in, if you plugged in 2 on both sides, that it would be equal. If you plugged in 7 on both sides, it would be equal. Anything would work on that one. Okay. All right, let's try another. Start cleaning this up by distributing. Okay, 2 times 6x and 2 times negative 3. 3 times 4x is 12x. 3 times negative 2 is negative 6. Let's combine the 12x's. Okay, those will cancel. Now I've got a true statement, so again, that's going to be infinite solutions. Okay, so we're going to get to some word problems next. And these are tough word problems, I think. If I were writing the book, I would not put problems like this right at the beginning of an Algebra 1 course. But that's where they are, and so that's what we're dealing with, okay? So you have to know this little formula, distance equals rate times time, to do these next couple of word problems. So if you think about driving, let's say you're driving at 50 miles per hour. Well, the rate is the speed. You can think of this as the speed here. That's the same as the rate, okay? So 50 miles per hour, and let's say you drive for 2 hours. Well, 50 times 2 would be 100 miles. It means you would travel 100 miles if you go 50 miles an hour for 2 hours, okay? All right, so with that in mind, let's take a look at this problem. Smeagol travels 2 hours upstream in his canoe to reach the farmer's market. His return trip home takes 1.5 hours because the canoe travels 3 miles an hour faster with the current. And then we want to figure out what the rate is on his way back. Okay, so I'm going to draw a little picture here. So here is Smeagol's house. I just put an S in there for Smiegel's house, okay? And then over here, this can be the farmer's market. It's a pretty realistic picture of a farmer's market there, right? Okay, so then there's a river that goes, he can take his boat from one to the other. And if you think about the distance from Smiegel's house to the farmer's market, I'll put a lowercase d here for the distance. That's going to be the same as the distance back, right? The distance from your house to school is the same as the distance from school to your house. It's the same distance when you go there or come back, okay? All right, so that's why I have the distance there and the distance back set equal to each other, okay? And then you need to know that the distance is going to be equal to the rate times the time for both of those, okay? So keeping that in mind, I'm going to start plugging numbers in from the problem into this equation that I've set up, all right? So Smeagol travels for 2 hours upstream. This is talking about going there. The 2 hours is on the way there because it says to reach the farmer's market. So we're going this way, so that is the time spent traveling on the way there, okay? All right, so let's see. His return trip home takes 1.5 hours. So that's how long it takes him to get home. That's the time going back, okay? So we got that one in there. And it says the canoe travels 3 miles an hour faster with the current. So it's going to go faster on the way back because it takes less time to get home, okay? So if the rate over here, I'll just call this R. I'll use an R there for the rate. That's the speed on the way there. The speed on the way back is faster. It's 3 miles an hour faster. So whatever this speed was, if this is 100 miles per hour, this would be 103 miles per hour, okay? And then since this represents the distance there, this represents the distance back, these should be equal to each other. And now I'm going to be able to find the speed for both the way there and the way back, okay? So the speed on the way there is going to be R. The speed on the way back is going to be R plus 3. Okay, but first thing we need to do is find R. So let's see, you could write this left side as 2R. On the right side, we'd want to distribute this to get rid of the parentheses. Okay, 1.5R, and then 1.5 times 3 is going to be 4.5. Okay, and now I'm going to start solving this for R. So I want to get these R terms on the same side. I might as well pull all my R's on the left so that it's separated from the 4.5. So that's what I'll do here. Okay, those will cancel. And then 2 minus 1.5 would be 0.5, or 1/2. So I got 0.5 R equals 4.5. And then the last step to find R would be to divide by 0.5. Okay, those will cancel. And you can put those into a calculator, but what we're doing here is dividing by 1/2. And dividing by 1/2 is the same as multiplying by 2. So I think you'll find if you put that into a calculator, 4.5 divided by 0.5, it's going to equal 9. Okay. Now this is the speed. So we're talking about miles per hour here because if you look in the problem, that's the units we're using for speed. Okay. Now it's really tempting to say your answer, okay, what's the rate on the way back? Oh, it's 9 miles per hour. But hang on, this is the rate on the way back. This is the rate on the way there. On the way there, it's 9 miles per hour because that's where the R goes. So this is their speed. But that's not what we want. We want the speed on the way back. Okay, so my way back speed is going to be R plus 3. That's this, right? So that's going to equal 9 plus 3, and that means we've got 12. And then I do need the units because what are we talking about? 12 inches per year? No, we're talking about 12 miles per hour. So that is really important. I'm going to just put MPH for miles per hour. Okay. And you could try plugging in the 12. Plugging in 9 for R. You'd get 18 over here if you multiplied. So the distance there is 18. And if you plug in 9 over here, you'd have 12 times 1.5, which is also 18. So those distances come out the same. Okay. So there's a lot going on in that problem. Okay, let's try one more of these. All right, this time Deagle is traveling to the farmer's market and then back home. There and back again. See what I did there? All right, anyways, here's Deagle's house. And then here is the farmer's market. Okay, and here's the stream that he can use. There's my stream. All right, the distance there is the same as the distance back. Okay, it says Deagle travels for 3 hours upstream in his canoe to reach the farmer's market. So traveling upstream means, you know, the current is going that way. It's going against the current. So 3 hours is the time spent traveling there. Okay, so got that one in there. His return trip home takes 2 hours. Okay, that's the time on the way back. Got that one in there. And then it says the canoe travels 4 miles per hour faster with the current. So if this is the speed going there, say that was 10 miles per hour, well then this is going to be 4 miles faster than that. So if this is 10, it's going to be 14 miles per hour going home. Okay? All right, because you'd be going with the current on the way home. All right, so those are equal to each other, and now I can use this to solve for r. So that would be 3r on the left. On the right, we need to distribute. I've got 2r plus 8. Okay, now I want to solve this for r. I want to combine these r terms. So I'm going to subtract 2r. That way, you got your r's on a different side than the 8. So let's see, 3r minus r, 2r is 1r. And that means that's the rate. Now that's the rate on the way there. That's my their speed. Okay, and now we got to read the question very carefully to make sure we understand what they're asking for. They're not actually asking for a speed in this problem. We need to know the speed, but to get the final answer, but that's not what they're asking for. It says, how far from home is the farmer's market? So we want to know what this distance is. Okay, and it doesn't really matter if we're using the distance there or the distance back because they're equal to each other. All right? So let's just try it out. Distance there. Well, that's going to be r times 3, or 3r. And now I know that the speed on the way there is 8. And that's going to equal 24. Okay, and so since we're talking about miles per hour, a distance, that's going to be in miles. Okay, and just to check it out, let's see what the distance back would come out to, because that should be the same. Okay, so we're going to use r plus 4 times 2. I'm just looking up there what I figured out before. So r is 8. Okay, and then 8 plus 4 is 12. 12 times 2 is 24. And it's the same either way, right? So it doesn't really matter which one you find, but it's a nice way to check it. It works going either direction. All right? Okay, that's the end of the section, and I'll see you next time.